Imagine the universe as a vast ocean of darkness, where time and space bend under the weight of colossal galaxies. Within this immensity, matter and energy dance in a delicate balance, governed by the invisible force of gravity. Billions of stars emit their light through the vacuum, revealing the presence of particles that tell the story of everything that exists. It is in this scenario of unimaginable proportions that we find our home, a small pale blue dot floating in a cosmic firing range. Often we look at the night sky and see only bright static points, but the reality is much more dynamic and dangerous. The solar system is not just a collection of planets orbiting a central star, it is the result of a primordial chaos that shaped every rock and every gas giant we know today. Throughout the centuries, humanity has tried to decipher the mysteries surrounding our immediate neighborhood. From Galileo's first observations, which mistook distant planets for fixed stars, to modern missions crossing the boundaries of the heliopause, our journey of discovery has been marked by constant surprises. The history and exploration of the solar system lead us to question, how did such a hostile and violent environment allow the stability necessary for the emergence of life? To understand this, we need to delve into the dynamics of formation and protection that define our existence. We are talking about a system where giants act as sentinels, clearing the path of deadly debris, while smaller worlds bear the scars of a brutal past. The study of these celestial bodies is not just a quest for academic knowledge, but an investigation into our own survival. Each mission sent into space, each spacecraft that falls silent after years of service, and each image captured by state-of-the-art telescopes brings us closer to a deeper understanding. We are experiencing the first steps of a species that has learned to look outward and recognize its fragility in the face of the grandeur of celestial mechanics. Space exploration shows us that what today seems like a safe haven was once a maelstrom of gas, dust, and catastrophic collisions. By observing the limits of our system, we realize that the boundary between order and chaos is much thinner than we would like to believe. On this journey, we will visit everything from the fiery bowels of the Sun to the icy dark plains of Neptune, a world that remained hidden for over 140 years after its theoretical discovery. Prepare for a technical and emotional immersion into a territory where each discovery solves an enigma, while opening up a dozen new questions about our place in the cosmos. Understanding the solar system requires looking beyond the visible surface of the planets and considering the forces that keep them in their orbits. The Sun, the beating heart of this system, concentrates almost all the available mass, exerting a gravitational influence that extends for billions of kilometers. However, the solar system is much more than just the Sun and the 8 main planets. It is composed of millions of small celestial bodies, natural satellites, and ring systems that form a complex network of interactions. One of the great mysteries that astronomers try to solve is the discrepancy between the theoretical formation of planets and what we actually observe in space. Why, for example, does Mercury have an iron core so disproportionate to its size? Why did Mars never reach the dimensions of Earth or Venus, remaining a cold, dry desert? These questions lead us to consider the theory of chaos in planetary formation. It is believed that in the first few million years, the solar system was a place of extreme violence, with protoplanets colliding and being ejected from their original orbits. The presence of gas giants like Jupiter and Saturn was fundamental to this process. Jupiter, with its colossal mass, acts as a large gravitational shield, deflecting comets and asteroids that could otherwise frequently and catastrophically strike Earth. This protection, however, is a double-edged sword. The same gravity that protects us can also hurl objects in our direction, as we have seen in historical events of significant impacts. Robotic exploration has allowed us to see these dynamics up close. The Voyager missions, as they traversed the outer solar system, revealed worlds that were previously just blurs of light. Neptune, the blue giant, was discovered not through initial direct observations, but through mathematical calculations that predicted its existence due to irregularities in Uranus's orbit. This demonstrates the power of science to predict the invisible. Upon reaching Neptune, we discover a world of supersonic winds and a moon, Triton, orbiting in retrograde motion, suggesting it was captured from the Kuiper Belt in the distant past. Every detail of these distant worlds helps us piece together the puzzle of our own origin. Analysis of ancient meteorites found on Earth provides chemical clues about the protosolar nebula, the cloud of gas and dust from which everything emerged. Within these space rocks, We find iron isotopes that could only have been created in the heart of massive stars that exploded as supernovae. This indicates that our solar system was born in a dense stellar nursery, surrounded by thousands of other stars, in a much more populated environment than the relatively isolated region where we find ourselves now. This connection between the micro and the macro, between the particles trapped in a meteorite and the explosion of a distant star, is what makes astronomy such a fascinating science. It forces us to recognize that we are made of stellar material and that our history is intrinsically linked to the history of the galaxy. By exploring Jupiter's moons like Europa or Saturn's moons like Enceladus, we seek not only geology, but signs of environments that could harbor life beneath kilometers-long ice crusts. The possibility of subsurface oceans on these worlds challenges our definition of habitable zones and expands the horizons of biology. We are at a crucial moment in our history, where technology allows us not only to observe, but to interact with these celestial bodies. The DART mission, which tested the deflection of an asteroid, is an example of how we have gone from passive observers to active agents in our planetary defense. The complexity of the solar system is vast, but our ability to unravel it grows each year, driven by an insatiable curiosity and the need to secure the future of our species amidst the uncertainty of the vacuum. The vastness we explore reveals an uncomfortable truth. We are inhabitants of a small oasis, surrounded by an environment of extreme hostility. The study of the dynamics of the formation and protection of the solar system shows us that the stability we enjoy today is an exception, not the rule. The order we observe in planetary orbits was bought with billions of years of chaos and destruction. Every crater on the Moon, every scar on Mercury, and every ring system around the giants are records of a gravitational war that still leaves its traces. Recognizing this reality is the first step in understanding the importance of science and constant monitoring. We are not just on a journey of aesthetic contemplation, we are on a mission of territorial reconnaissance. The exploration of worlds like Mars or the icy moons of the outer system aims not only to find extraterrestrial life, but also to understand how planets die or how they maintain favorable conditions for so long. The fragility of Earth becomes evident when we compare our planet with neighbors like Venus, transformed into a hellish greenhouse, or Mars, which lost its atmosphere to space. These divergent destinies serve as a stark reminder that balance is delicate. The technology we develop to explore the cosmos is the same technology that may, in the future, save us from sudden extinction. The awareness that we live in a cosmic firing range should be the driving force behind our technical and ethical responsibility. As a conscious species, we have a duty to transform scientific knowledge into tools for active survival. At the end of this initial reflection, it is clear that the solar system is a magnificent structure of mutual protection and imminent danger. The gas giants continue their silent patrol, clearing the way for life to flourish within the system, while the sun provides the energy that powers the entire biosphere. However, the silence of space should not be mistaken for absolute safety. There are gaps in our understanding that still need to be filled, mysteries hidden in the shadows of polar craters and in the depths of the ammonia oceans of the outer planets. The journey we begin here seeks to reconcile these apparent paradoxes: beauty with violence, order with chaos, and our insignificance with our capacity to comprehend the whole. We are a small blue dot, yes, but we are a dot that has learned to calculate the trajectory of the stars and to cast its own light into the darkness. The closing of this first stage of our investigation prepares us to look more closely at the protagonists of this story, beginning with the pillars of stability that hold the solar system together. The promise of a panoramic view of our origin is only beginning to be fulfilled, and what we find next will further challenge our perception of what it means to be safe in the universe. Imagine a colossal sentinel, a world so vast it could contain more than 1,000 Earths within it, wielding a gravitational sovereignty that defines the fate of the entire solar system. Jupiter is not only the largest of the planets, it is the architect of order and the guardian of the stability that allows for the existence of smaller, rocky worlds. Alongside Saturn, with its shimmering rings that tell the story of shattered moons and eternal ice, these gas giants form the backbone of celestial mechanics in our neighborhood. The majesty of these worlds is complemented by complex systems of natural satellites, each functioning as a unique geological laboratory. From Io, with its volcanoes spewing sulfur into the vacuum, to Europa and Enceladus, where oceans hidden beneath layers of ice challenge our understanding of where life can flourish, the study of these regions is fundamental. The organization and gravitational balance observed here are the result of a millennia-old dance of mass and energy. When we look at the high-definition images captured by probes that have traveled billions of kilometers, we see not just spheres of gas and dust, but the pillars that support the cosmic architecture. Saturn, with its density so low it could float in an imaginary ocean, and Jupiter, with its great red spot that has roared for centuries, are the protagonists of a narrative of power and protection. They shaped the asteroid belt, preventing the formation of a fifth rocky planet and creating a natural barrier. Understanding these giants is understanding the rules of coexistence in the solar system. The exploration of these boundaries has revealed to us that what we call a void is in fact full of magnetic interactions and flows of charged particles. Each moon, each ring fragment, and each storm in the upper atmospheric layers of these worlds contributes to a delicate balance. The central thesis we explore here is that without the presence of these colossi, Earth and the other inner planets would be at the mercy of a constant bombardment of primordial debris. The harmony we perceive in the night sky today is an active construction of these giants. They are the thermal and gravitational regulators that transform a chaotic accretion disk into an organized system. As we travel through the boundaries of these domains, we realize that the aesthetic beauty of Saturn and the brute force of Jupiter are two sides of the same coin. The need for a centralized structure so that the complexity of life could find a way. This is the celebration of order over chaos, where mass becomes the ultimate tool of creation. To delve into the complexity of the gas giants, we need to understand the scale of their influence. Jupiter acts as the solar system's great vacuum cleaner. Its immense gravity captures or deflects long-period comets that would otherwise cross its inner orbits with lethal frequency. This protective phenomenon is not merely theoretical. It was observed in real time when comet Shoemaker Levy 9 was torn apart and absorbed by the giant in 1994, a clear demonstration of the sentinel role this planet plays. However, the influence of these worlds goes beyond ballistic security. The planetary migration of Jupiter and Saturn shortly after the Sun's formation, described by models such as the Grand Tack hypothesis, suggests that they moved inward and then outward from the system, clearing space material and determining the final size of Mars and Earth. Saturn complements this dynamic with its ring system, which is in effect a dynamic graveyard of ice and rock. These rings are held in balance by small shepherd moons that, through orbital resonances, prevent the material from dispersing or collapsing. It is a mathematical demonstration of physical perfection where gravity acts as a chisel, sculpting structures that extend for hundreds of thousands of kilometers but are only a few meters thick. Further down in the depths of these atmospheres, the pressure is so extreme that hydrogen becomes metallic, generating vast magnetic fields that protect their moons from direct solar radiation, but creating radiation belts of their own that are technological challenges for our probes. The moons of these giants are worlds in their own right. Titan, Saturn's largest moon, has a dense atmosphere and methane cycles that mimic the water cycle on Earth, offering a glimpse into an alternative prebiotic chemistry. On Europa, Jupiter's gravity flexes the moon's core, generating heat through tidal friction and maintaining a liquid ocean beneath the ice. This mechanism transforms what should be a dead world into one of the most promising places for the search for biosignatures. The thesis of order is reinforced when we realize that even the most violent events in these worlds, such as the hexagon storms at Saturn's North Pole, follow patterns of fluid dynamics that we can predict and study. The exploration of these systems has taught us that stability does not mean stagnation. Gravitational equilibrium is a constant negotiation of forces. When we observe Saturn's ring system, we are seeing matter in a state of eternal transition, a reminder that the organization of the solar system is a continuous process. The precision with which the Galilean moons orbit Jupiter, in perfect 1 to 2 to 4 Laplace resonances, is one of the most elegant visions of classical physics. This large-scale organization is what allowed the inner solar system to remain relatively untouched for billions of years, giving time for biological evolution to occur. The greatness of these gaseous worlds lies not only in their size, but in their function as anchors of planetary reality. Without Jupiter and Saturn, the map of our existence would be radically different, possibly reduced to a debris belt without a safe haven for the development of consciousness. With each new discovery from the Juno or Cassini missions, we confirm that the architecture of these giants is the foundation upon which all the diversity of the solar system was built. As we consolidate our understanding of the gas giants, we realize that the thesis of order and protection is the dominant narrative of the outer solar system. Jupiter and Saturn are not merely distant neighbors. They are the fundamental pillars of a structure that prioritizes stability through mass. The organization of the moon systems and the precision of the rings are evidence of a celestial mechanic that works tirelessly to maintain balance. The protection offered by Jupiter, deflecting external threats and clearing the path for the rocky planets, establishes an environment where life could thrive on Earth. This apparent harmony is the triumph of gravity as an organizing force, transforming the chaos of the Primordial nebula into a lasting and functional configuration. The beauty of these massive spheres and their orbital dances reflect a universal law of preservation. However, this technical perfection and the security provided by the giants conceal a parallel reality. While we celebrate Jupiter's order, we ignore the scars that the same primordial violence left elsewhere. The stability we enjoy here is the result of a natural selection of orbits, where only the strongest or most protected survived. For every world in equilibrium, there were others that were shattered or hurled into the interstellar abyss. The same force that protects us today is what caused destruction in the past. When we look at the giants, we see the face of order, but we must not forget that this order was forged in fire and collision. The grandeur of Jupiter and Saturn is a reminder that security depends on scale, and that in the universe mass is destiny. This vision of an organized and protected solar system is comforting and grounded in solid data, but it is only half the story. There is a dark side to this celestial mechanics, a side where protection failed, and where disorder left permanent marks that we can still touch. If the giants represent the thesis of order, there are worlds that represent the absolute antithesis of everything we have just described. Planets that were not protected, but rather shaped by the purest violence that space can offer. To fully understand the solar system, we must now shift our gaze from the organized majesty of Jupiter to the brutal solitude of worlds that faced chaos without any shield. The transition to the next phase of our journey will lead us to an environment where order gives way to destruction, revealing a far more complex truth about our cosmic neighborhood. If the gas giants represent the architecture of preservation, Mercury is the silent testament to devastation. This small world, the closest to the sun's fiery bowels, defies the logic of formation we observe in the rest of the solar system. While Jupiter and Saturn boast gaseous layers and organized systems, Mercury presents itself as a planetary shell, an exposed metallic core bearing the scars of a past where protection was non-existent. The surface of this planet is a catalogue of violence, dominated by gigantic impact basins and scarps that suggest the entire world shrank as its interior cooled. Observing Mercury, we are confronted with the antithesis of stability. Here, proximity to the central star means being lashed by relentless solar winds and thermal variations that can melt lead or freeze gases in a matter of hours. There is no atmosphere to soften the blows, no robust magnetic shield to deflect charged particles. What remains is a desert of dust and rock that forces us to question, what happened to the material that should form this planet's mantle? Exploration through the Mariner 10 and Messenger missions has revealed that Mercury is essentially a geological error of catastrophic proportions. Its density is anomalous, suggesting that the outer layers were torn away by massive collisions early in the solar system's history. This is the domain where chaos triumphed over order. While we celebrate Earth's safety, Mercury reminds us that the universe has no favorites. The fragility of planetary existence is exposed in every inch of its rugged terrain. Studying this world is like performing an autopsy on a survivor of an event that should have completely destroyed it. It is a reminder that the solar neighborhood was, for a long time, an environment of planetary extermination. Mercury's existence challenges simplistic theories of matter accretion, proving that destruction is a force as creative as gravity itself. At this stage, we set aside the harmony of the spheres to confront the brutal reality of a world that faced the void defenseless. Technical analysis of Mercury reveals an internal structure that appears to belong to a much larger planet. Approximately 75% of its radius is composed of an iron core, a proportion unparalleled in any other known rocky body. The most widely accepted explanation for this anomaly is that Mercury was the victim of a colossal impact during its planetary differentiation phase. A projectile the size of a small planet would have struck the young Mercury, vaporizing most of its silicate crust and mantle, leaving behind only the dense core. This scenario of absolute destruction is the antithesis of the protection provided by the gas giants. While Jupiter was clearing the outer system, the inner system was a theater of high-energy collisions. The Messenger mission, orbiting the planet for 4 years, yielded data that deepened this mystery. It was discovered that the surface is rich in volatile elements such as potassium and sulfur, substances that should have been evaporated by the extreme heat of the Sun or by the initial impact. This suggests that Mercury's formation was even more complex than we imagined, perhaps involving the capture of material from different regions of the solar nebula. Furthermore, Mercury possesses a magnetic field, although it is only 1% of Earth's. This field is shifted northward, creating an asymmetry that allows solar plasma to directly reach the surface at the South Pole. It is a world of extremes where ice can exist at the bottom of permanently shadowed craters at the poles, just a few kilometers from plains that burn under direct sunlight. This coexistence of ice and fire on a world without an atmosphere is one of the greatest contradictions in the solar system. Mercury's geology also tells a story of global contraction. Large geological faults known as wrinkles crisscross the planet, indicating that it has shrunk in size by up to 7 kilometers in radius as its immense iron core cooled and contracted. It is a planet that is literally withering. Comparing this fate to Earth's stability allows us to appreciate the defense mechanisms we possess. If Earth had formed in Mercury's orbit, its history would have been written in impacts and radiation, not oceans and life. The absence of a moon also contributes to this world's geological solitude. Without tidal stabilization or the additional shield of a satellite, Mercury is entirely at the mercy of the Sun's gravitational forces. This relationship of submission to the central star has shaped its peculiar rotation, where the planet spins 3 times on its axis for every 2 orbits around the Sun. This means that a solar day on Mercury lasts 2 Mercurian years. It is an environment where time and physics seem distorted by the violence of stellar proximity. Every discovery made about this small planet serves as a necessary counterpoint to the vision of a perfectly ordered solar system. Mercury is proof that selective destruction is a fundamental component of cosmic evolution. It is the survivor of an internal cleansing process that removed excess mass, leaving behind a monument to the resilience of matter under the harshest possible conditions. The reality of Mercury establishes the ultimate antithesis to the concept of absolute protection. This world shows us that security is a privilege of location and circumstance. While the gas giants established the boundaries of order, the inner planets faced a regime of violence that Mercury exemplifies, with its anomalous structure and devastated surface. The lack of a thick mantle and direct exposure to solar rigor have transformed it into a fossil of chaos that most of us prefer to ignore. By studying the Mariner 10 and Messenger missions, we realize that the history of the solar system is punctuated by immense losses and brutal transformations. Mercury is not just a small planet, it is what remains of a planetary promise that was interrupted by the most aggressive celestial mechanics. This vision deconstructs the idea that the solar system is a perfect and immutable clockwork mechanism. On the contrary, it reveals a past of instability where worlds were undone so that others could remain. The fragility we observe here is a constant reminder that Jupiter's protection has limits and that the inner solar system was shaped by fire. However, facing this destruction should not be a reason for pessimism. The same violence that tore away Mercury's outer layers is what distributes the chemical elements necessary for the formation of other rocky worlds. There is a lesson of survival in the calcined rocks of this planet. Mercury's existence, despite all the forces against it, is a testament to the persistence of matter. This perception leads us to a point of profound reflection. If the order of the giants and the chaos of Mercury are simultaneous truths, how can we reconcile these two states? The history of the solar system is not just about protection or just about destruction, but about the continuous interaction between both. We need to find the connecting thread that unites the gaseous sentinel to the exposed metallic core. To move forward, we must seek a synthesis that explains how this duality between security and threat defines our own chance for the future. Our next step will not be about looking at the past of one or the structure of the other, but rather about how humanity uses knowledge from these two realities to build its own shield. The synthesis between order and chaos manifests itself in our ability to anticipate danger and act upon it, transforming scientific observation into active defense. The duality between the majestic order of Jupiter and the brutal devastation of Mercury leads us to a frontier where scientific knowledge transforms into a tool for survival. Understanding the solar system is no longer just a matter of curiosity about galaxies or matter, but a pragmatic necessity for defense. The synthesis of this narrative lies in our ability to reconcile learning about primordial chaos with modern technological application. The universe is a constantly moving field of forces, where gravity dictates the rules of a survival game in which Earth is the main prize. By observing the stars and particles that compose space, we realize that the protection we enjoy is not guaranteed forever. The history and exploration of the solar system have taught us that although we have giant sentinels, danger can come from unexpected directions and on varying scales. Humanity has reached a stage of technical maturity where we are no longer just passive passengers on this space rock. We are learning to manipulate the energy and trajectory of celestial bodies to ensure that the fate of Mercury is not repeated here. Time is a precious resource, and the light we capture from distant objects gives us the necessary warning to act. This phase of our development as a conscious species focuses on the union between astronomical observation and aerospace engineering. It's not just about mapping what's out there, but about building an active shield that utilizes the same laws of physics that once caused destruction. The synthesis, therefore, is the transformation of vulnerability into vigilance. We are crossing the threshold between being a species that fears the sky and a species that monitors and shapes it for its preservation. Earth's security now depends on our ability to integrate the lessons of thesis and antithesis into a robust planetary defense strategy. This is the moment when science ceases to be contemplative and becomes defensive, uniting the past of collisions with a future of directed stability. The practical application of this synthesis is evident in projects that once seemed like science fiction, such as the DART mission. This asteroid redirection test was the first real step in demonstrating that we can alter celestial mechanics to our advantage. By colliding a probe with an asteroid satellite, humanity proved that the transfer of kinetic momentum can deflect a collision trajectory. This feat reconciles the brute force of gravity, which shaped Mercury, with the mathematical precision that governs Jupiter's moons. However, planetary defense requires more than just impact capability. It demands constant monitoring and infrared imaging to detect objects hidden in the sun's glare. Events like the Chelyabinsk event in 2013 served as a stark warning. Small space rocks can cause significant damage without warning if we are not vigilant. The Global Surveillance Network now uses ground-based and space-based telescopes to catalogue nearly all near-Earth objects with dimensions capable of causing regional or global extinctions. Beyond asteroids, we monitor the sun itself. Solar storms, massive explosions of radiation and charged particles represent a direct threat to our technological society. A large-scale coronal mass ejection has the potential to paralyze power grids and communication systems for years. The key here is understanding that the sun, the provider of life, is also the greatest source of immediate instability. We have about 3 days to react to a large solar flare before the particles reach our magnetosphere, time that should be used for contingency plans, such as the preventive shutdown of satellites and power grids. This cyclical monitoring, which follows the 11-year rhythm of solar activity, is proof that our survival is linked to our ability to read the signals of the cosmos. Knowledge about the impact basins on Mercury and the dynamics of Jupiter has given us the context to understand that the solar system is still an active environment. Planetary defense is the ultimate manifestation of human intelligence, attempting to balance order and chaos. We are learning to utilize the planet's own gravity through gravitational assists to position our defenses at the most strategic points in space. The exploration of moons like Europa and Enceladus also contributes to this synthesis, as it teaches us about the resilience of life in extreme environments, expanding our understanding of what we are truly protecting. Ion propulsion technology and artificial intelligence for trajectory detection are the new tools of this era. By merging planetary geology with orbital physics, we are creating a new discipline of survival. We are not just avoiding the end, we are ensuring that the complexity achieved on Earth can continue to evolve. This integration of data and action is what sets us apart from any other phase of Earth's history. The shield we are building is invisible, made of equations, sensors, and the collective will to not allow the history of destruction of the inner solar system to repeat itself on our home planet. The synthesis between protecting the giants and destroying the inner worlds culminates in our technical responsibility as guardians of life. We have learned that the solar system is a complex mechanism where security is the result of uninterrupted vigilance. The DART mission and the monitoring of solar storms are the pillars of a new era where scientific knowledge is directly converted into security for civilization. We are no longer victims of cosmic chance, but agents who are beginning to exert influence over the space environment. This transition from observers to defenders is the point of union between the thesis of order and the antithesis of chaos. We now understand that the gravitational balance that Jupiter maintains is the model we are trying to replicate on a smaller scale around Earth. Planetary defense is, ultimately, our attempt to give our planet the protective mantle that Mercury lost. This synthesis gives us the confidence to look to the future, knowing that the tools for our survival are already being tested and improved. The harmony we seek is not static, but a dynamic harmony maintained by human effort and technological precision. By reconciling our violent past with our present capabilities, we create a narrative of hope, grounded in reason. However, this new position of power brings with it profound questions about our role in the universe. Are we safe enough to expand our presence beyond Earth? The monitoring we do today is the prelude to something much greater than simple defense. By mastering the laws that govern the solar system, we open the doors to a final understanding that transcends mere survival. The journey that took us from Jupiter's moons to Mercury's craters now converges on a conclusion that ties all these threads together. We are ready to understand not only how the solar system works, but what our presence in it means for the future of life. The next step will be the closing of all cycles, where the fragility of our blue dot will be definitively integrated into the grandeur of celestial mechanics, revealing the complete picture of our journey through the cosmos. The journey we have undertaken, from the colossal domains of Jupiter to the deep scars of Mercury, brings us back to our starting point with a renewed vision. The universe, in its scale of time and space, has revealed itself as a system of contrasts where matter and energy seek a precarious balance under the aegis of gravity. We understand that galaxies and stars are not merely distant backdrops, but the sources of the particles and light that define our immediate reality. The history and exploration of the solar system have shown us that the stability we enjoy is the result of a complex interaction between the protection offered by the gas giants and the exposed vulnerability of the inner worlds. To revisit this context is to recognize that we live in an oasis of order, surrounded by a history of chaos. We have seen how Jupiter and Saturn act as sentinels, clearing the planetary path, while Mercury remains as a reminder that, without defenses, the fate of a world is fragmentation and erosion. The contradiction between the thesis of security and the antithesis of destruction found its conciliatory factor in the synthesis of planetary defense. Now, as we look to the future, we realize that our technical responsibility is what ties these threads together. The promise of a panoramic view of our existence is fulfilled when we understand that science has given us the shield that nature denied to smaller worlds. We are ready for the final integration of all these concepts. The definitive connection between Jupiter's order, Mercury's chaos, and Earth's vigilance reveals that the solar system is a living organism in terms of physical dynamics. There is no isolated element. The trajectory of an asteroid deflected by Jupiter billions of years ago may be the reason why Earth has water and life today. Similarly, Mercury's metallic shell serves as the instruction manual on what to avoid through our monitoring technology. The final explanation of this network of interdependence shows us that humanity is the first species capable of reading the map of its own survival. But here, the cold logic of celestial mechanics gives way to a much grander and deeper perception. When we look at the immensity of the vacuum, we don't just see rocks and gases in motion, we see our own history written in scales of light and shadow. The feeling of insignificance in the face of the magnitude of the forces at play is replaced by a sense of technical and existential purpose. We are the brain of the solar system trying to protect the heart of life. The contradictions we explore, such as the violence that generates order and the protection that hides danger, are the gears of a clock that we are only now beginning to understand. The absolute truth is that the peace we feel when we look at the night sky is an active construction of monumental forces and vigilant human minds. Each probe sent, each orbit calculation, and each solar storm warning are the beats of this defense system we have built. However, even with all our progress and all our vigilance, one question remains, echoing in the void. There is one last gap in understanding that science has not yet been able to fully fill. It is the silence that precedes the final realization that, despite all our knowledge, we are still dependent on a balance that we do not fully control. The final word in this journey is reconciliation. All the paradoxes presented, from the fury of the sun to the apparent calm of Earth's orbits, find their resolution in our awareness that we are an integral part of this mechanism. We conclude here the cycle of investigation that began with the observation of Neptune's boundaries and Galileo's first doubts. We highlight Mercury's internal structure no longer as a frightening anomaly, but as a lesson in resilience. We recognize the gas giants not only as distant neighbors, but as the architects of our security. The tying together of all this content leads us to the conclusion that the history of the solar system is our own biography on a cosmic scale. The technical knowledge we have accumulated from missions like Voyager, Messenger, and DART is the legacy we will leave for future generations of explorers. The fragility of our small pale blue dot is, paradoxically, its greatest strength, for it was this vulnerability that propelled us to understand the universe. The conclusion of this project leaves us with absolute clarity. Security is not a state of rest, but a process of continuous discovery. By mastering the narrative of our origin and the forces that surround us, we transform the fear of the unknown into respect for the complexity of nature. The solar system will continue its dance for billions of years, with or without our presence, but the fact that we have been able to decipher its laws and protect our home is what confers greatness upon our species. We conclude this narrative with the certainty that space exploration is ultimately an act of love for life and a commitment to the future. The silence of space is no longer empty. It is filled with our curiosity and with the machines we send to say that we are here and that we are watching. The complete picture has been revealed. We are the guardians of a balance forged in chaos and maintained by reason. Our journey through the cosmos is only beginning.